Hallo, it's Dumplet here. Here's an item on geometry. In the figure shown below, ABCD is a right-angled trapezoid. If AB equals AE equals 4 centimeters, DE equals 8 centimeters, and CD equals 16 centimeters, what is the area in square centimeters of triangle BCF? Now credits to the Hong Kong Polling Corp, 香港保良局 for this question. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, since we have a lot of right angles in the given, we are given that it's a right angled trapezoid, so this angle would be right, this angle would be right. And then here we have given some of the lengths here, so we can try to take advantage of that, and we're going to work on this item in the Cartesian plane. So we're going to use the Cartesian coordinate plane to help us plot some points, and then we can work on from there. So the first step is to locate the origin. Now, generally you can locate the origin wherever you want, but in the context of this question, let's put our origin at point D, because it seems to be like the intersection of two perpendicular lines, AD and DC. So I guess it makes sense for us to put the origin at point D. And we're going to label the rest of the points and using the given. So since we have CD equals 16, so let's take a look at this. CD equals 16. This will give us that C should be 16 units, well, to the right, based on the figure. So C would be at the point 16, 0. That's from, right, just from moving to the right in the Cartesian, on the Cartesian plane. And next, for the point E, we can use the fact that DE is 8. So just move 8 units up based from the figure. So 0, 8 it is. And then we know that AE equals 4. So another 4 units up, hitting 0, 12. And then AB is 4 as well. So moving to the right 4 units, this becomes 4, 12. And basically we have exhausted all the given. And we have A, B, C, D, E plotted in the plane. Now here we have a point F, which is going to be the next target. Now we can get the point F as follows, because based on the question, based on the given, F seems to be the intersection of these two lines here, the blue and the green one. And then we can, since we're now in the Cartesian plane, we can try to get the equations of those lines. Since the blue line contains points B and D, we can use the 2 point, we can get the slope, we can use the points to get the equation. Same for the green line over there. Now, okay, for the blue line, it passes through the origin, so that's kind of nice. And then the slope, it's going to be the change in y divided by the change in x. So let's try to get the slope of the blue line. So m is equal to change in y, that's 12 minus 0, that's 12, divided by 4 minus 0, that's 4. So our slope here becomes 3. And well, since it passes through the origin, then it's going to take form y minus 0 equals 3 times x minus 0. Again, this is just from the point slope form, and that's just going to give us y equals 3x. So that's the equation of the blue line, or segment BD. Now next here, we're trying to get segment EC. Again, we can get the slope first. So m equals change in y, 8 minus 0, that's 8. 0 minus a change in x, 0 minus 16, that's negative 16. 8 divided by negative 16, that's negative 1/2. Now the slope is negative 1/2. Let's use 16, 0 for the point slope form. So y minus 0 equals the slope times x minus 16. Again, this is from the 2 point form, and we can kind of simplify this a little bit. We're going to get that the equation is y equals negative 1/2 x plus 8. Now on the other hand, since these two are intercepts, you could have used the intercept form, but whatever method works, I'll be curious that we get the line. Now we have two lines, and F is the intersection of the two lines, so we're going to do some system of linear equations here and then get x and y, because their point of intersection, the solution to this system of equations, it's going to be a point x comma y, so graphically it's going to mean point F. So we have y equals 3x and y equals -1/2 plus 8. Now I intentionally put those two in that format because we can simply equate those two equations, solve for x. So we have 3x equals -1/2 x plus 8. Let's add 1/2 x on both sides. That's going to give us 7/2 x. That's going to be equal to 8. All right, not the previous value of x. We're going to get that x is equal to 16/7. And we need the value of y. That's no problem because we have a nice first equation. Y equals just 3x. So y is just 3 times 16/7. And that's going to give us that. Y is just 3 times of this, so 48/7. And there we go. X comma y is 16/7, 48/7. So putting it back in the graph, in the figure, we have point F with coordinates at 16/7, comma 48/7. All right, now going back to the question, we're asked to get the area of triangle BCF. And since we have points in the Cartesian plane, and now we have all the points of all the vertices of the triangle BCF, we can use the shoelace method to help us get the area. All right, so let's take those 3 points and let's try to use the shoelace method. Now for the shoelace method, you're just going to write the points kind of vertically. So again, it doesn't really matter which order you do it in. I decided to put 16/0 as my first point, this as my second, and then this as my third. And you have to write it in left to right, in the order left to right. So this will be the first point, the second point, the third point. Again, it doesn't really matter the order. The only thing that matters is that make sure you duplicate the first point you've written down. So in this case, 16/0 is my first point, and then you see here, I repeated 16/0 again. That's required for the shoelace method. Now, after we write the points in this way, we're going to use the following method. So draw the down arrows. So we have 3 down arrows in blue, and then 3 up arrows in red. And then we're going to perform 1/2 the absolute value of down minus up. But what's down, what's up? Down is the product of the 2 numbers that each arrow connects. So we have 3 arrows. The first arrow connects 16 and 48/7. The second arrow connects 16 and 48/7. The second one connects 16/7 and 12. The third arrow connects 4 and 0. And then we're going to take the product of each. 16 times 48/7. 16/7 times 12, and then the 4 and the 0, well, there is a 0, so I just didn't include it in the sum, but generally it's going to be the sum of the 3 products over here. So that's going to be for the down, as you can see here in blue, that's for the down, and then for the up, same thing, so 0 times 16/7, but it's just 0, that's why I didn't include it in the sum, 48/7 times 4, as you can see here, and then 12 times 16, and this is going to give us the up sum. There we go. Now, next is just to evaluate this thing. So 1/2 of down minus up. The down, you can evaluate this. You're going to get that this would be equal to 960/7. This would be and then you're going to realize that the red part, it's going to equal to, and then you're going to 192/7 minus 192. Oh, sorry, plus 192, but we're going to distribute the sign to remove the parentheses. And then we're just going to put this into one fraction, so we can easily work with it. So it's going to be equal to 960 minus 192 minus 1,344 divided by 7. And all we have to do is just to evaluate this part. Now, this part inside the absolute value equals negative 576/7. Again, absolute value, you can just remove the negative sign. So we're just left with 1/2 times 576/7. Now, the 2 and the 576, they're both divisible by 2. So we're just going to perform our final cancellation over here. So 1 and then 288, and multiply the get the product of those two, and then we're going to get the product of those two, and triangle BCF is going to be equal to 288/7. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.